All right. So first of all, what's your name?
I'm Molly.
And where do you work, and what is all here behind you?
I work at Johnson Space Center on the Orion spacecraft, but we're here promoting Orion and SLS, which is NASA's program to take humans beyond low Earth orbit to an asteroid or the moon or Mars. So we have people here from Huntsville, Alabama that work SLS at Marshall Space Flight Center. And then I'm here from JSC. And so really the purpose of Orion, the spacecraft, is our journey to Mars. The whole goal is to explore Mars and start trying to maybe habitat Mars and explore.
So we have a capsule design, and back in the Apollo days we had a capsule design, and in between there we had the really long-running 30-year shuttle program. So why no space plane this time? Why is there a capsule again?
A capsule shape is very good actually for coming back from deep space destinations, both for like aerodynamics, hypersonic aerodynamics. You're very blunt, which creates a lot of drag, which is good because you want to slow yourself down because you're coming back from a deep space destination, so you're going much faster than coming back from, say, low Earth orbit, like where the space station came back from. I mean, not the space station, the space shuttle from the space station on low Earth orbit. And so that blunt shape is very good from a drag perspective. It's a very stable shape. You don't have to worry a whole lot about guidance and all that because it is pretty stable from that perspective. And then also from heating, a very blunt shape pushes a shock wave, which is when you're going faster than the speed of sound, it gets very hot. And so you push the shock wave out in front of you with that blunt shape, which keeps the high temperature gases out away from your vehicle and it keeps you a little bit cooler. Then say a more pointy shape like the space shuttle has the shocks a little bit closer to the body, which is a little bit hotter if at the same comparable velocities. If that kind of, try not to go too detailed, but the gist of it.
So in other words, it's about surviving re-entry more than anything else.
Pretty much, yeah. A lifting body like shuttle would not get you back from Mars. No.
And we want to come home.
And we don't need that lift capability. It's not really necessary for right
And
now.
so the Orion is a pretty small spacecraft. It's a little bit bigger than the Apollo. It's probably about as wide as this little banner behind you here, this whole thing. A little bit, but pretty well the same size. So
6 meters, 5 meters.
So is there going to be a interplanetary habitat module that will be developed later for them to really kind of live in, to give a little bit more living area when we go out to an asteroid and later Phobos and Deimos and then finally land?
Yeah, you would hopefully take some kind of habitat with you for the journey out there, just to have a little bit more space for your astronauts on the way there. And then also you would have some kind of habitat or something that you would either send before you and it would already be on Mars, or you would take it with you as well.
So really the Orion is the first and last step of the mission.
Right, you would launch inside of there and then you would re-enter inside of there. It's just kind of carried along as your return capability.
And so is this version right here of the SLS going to be what takes this cargo up? Or is it just going to take the Orion up?
It's the same, basically all the way up to just above where the strings are, is the same rocket. But then the very top part is where the people are. And so you would change that out and you would have, cargo capability. But there are different versions of SLS scheduled. There's a 70-ton lifting capability, which would lift Orion with the humans in it. And then there's also a 130-ton spacecraft rocket planned that would not take the spacecraft, but it would take cargo, like habitats, those kinds of things, to Mars.
And my last question is, so human exploration seems to be the thing that everyone gravitates to because, we're human and we like to see humans go do things. But there's a whole lot of other things at NASA that, heliophysics, astrophysics, earth sciences, aeronautics research.
And we have some of those booths out here.
And I've stopped by and talked to all of them.
Yeah.
But how do all of these programs help human flight, and how does human flight help all of those other programs? Because it's one big NASA family.
Right, yeah. So, we do planetary sciences, different planets and, send robots and other rovers and things there. And that's really, kind of like scout missions, looking at the atmosphere, looking at the surface, looking at, if humans were to go there, what might we be able to see and work with? And so that's why we have the Curiosity rover on Mars, is, kind of scouting things out and taking rock samples and looking, what different parts of the planets have kind of what different composition and all those different kinds of planetary science. So it all works together. And like the space research that we're doing on the International Space Station, we're looking at how humans can alterations in space because your bones start losing density, your muscles start degrading a little bit, and for a mission to Mars, which might be 2 to 3 years, that's gonna be a lot worse than say just a 6-month stay on the space station. And so in 2 weeks, we're actually launching a cosmonaut and an astronaut that will live on the space station for a whole year, and we'll track their progress for a year, which will be the longest somebody's been continuously in space. So it definitely all works together, as we would need to know those things for a Mars mission.
And like the heliophysics lets us know about the interplanetary medium, and the aeronautics research makes it so that we can re-enter the Earth's atmosphere and Mars's atmosphere. So it's all one big, well, knowledge is power, and you got to have a lot of power in order to go to Mars.
Yep.
All right. Well, thank you so much. I appreciate